as sulfate is -2, 3 sulfates -6, and each iron therefore should be +3 because it is neutral. So +3. So by that we can understand manganese oxidation number changed, iron oxidation number changed, like this. Oxidation number changed means what to understand? That substance has either lost or gained electron. This is nothing but redox reaction. So any element's oxidation number if changed, you can say it is a redox reaction. Like this, redox reaction will be recognized. Further redox reactions, to understand, we can have a separate discussion on redox reaction, but today our very purpose to see these redox reactions is to decide N factor of a substance when acting as reducing agent or oxidizing agent. Now, if you look at this compound, it is an oxidizing agent. What we are saying is reactions are acid-base reactions, redox reactions, and hardly precipitation reactions. So, to decide the equivalent weights, N factors we understand for acids in one way, the bases the other way. Similarly, for redox reagents, it is done in terms of these electrons gained or lost. Here, potassium permanganate is an oxidizing agent. Why do you say it is oxidizing agent? Because it is by itself undergoing reduction from +7 state came down to +2. +7 became +2 means what? 5 negative charges gained by it. In other words, 5 electrons gained by this. Gaining of electrons what? Reduction. So, permanganate, potassium permanganate here got reduced. Anyone like that got reduced means acted as oxidizing agent. So, potassium permanganate's oxidizing agent role here decides its N factor. Similarly, ferrous sulfate. Here iron's oxidation number changed from +2 to +3. That means for FeSO4 there is a change in oxidation state indicating that it underwent oxidation. +2 became +3 means 1 electron further lost. So loss of electron is nothing but oxidation. So we say ferrous sulfate got oxidized. That means acted as a reducing agent. So for these redox reagents, oxidizing agents or reducing agents, to decide equivalent weight, that so-called N factor we understand in terms of these electrons lost or electrons gained. Suppose for this potassium permanganate N factor of potassium permanganate, we decide based on this is equal to 5. Why? Since 5 electrons gained. Similarly, N factor of ferrous sulfate is equal to 1 since 1 electron lost. So finally, what is N factor for an oxidizing agent? It is the number of electrons gained. What is N factor for a reducing agent? It is number of electrons by that lost. So overall we can say the total number of electrons lost or gained by one substance is called its N factor. So for redox reagents, the N factor is decided like this. Number of electrons gained or lost by each unit of that is its N factor. So N factor of redox agents equal to number of electrons gained or lost. Number of electrons gained or lost. Like that, when you look at a chemical reaction, first you understand the roles. A substance role is what? Acid or base or reducing agent or oxidizing agent. Then we can decide the equivalent weight based on the role. If it is an oxidizing agent, how many electrons gain? If a reducing agent, how many electrons lost? So generally for redox free agents we say number of electrons gained or number of electrons lost. If you know that, that is n factor. If n factor known, we can tell what is the equivalent weight. So for every substance, whether it is acting as a reducing agent or oxidizing agent, finding this n factor in terms of electrons lost or gained can be done by observing the changes in oxidation numbers. Finally, a small example. K2Cr2O7 when reacts with sulfur dioxide, an acid medium like sulfuric acid, produces chromic sulfate and sulfuric acid or sulfur trioxide also we can say. In this reaction, potassium dichromates the n factor, we say 6. Why n factor 6 we said? Because here dichromate's oxidation number is plus 6 and dichromate's chromium, in dichromate chromium's oxidation number let us say plus 6. Here chromium's oxidation number is plus 3. So from plus 6 state, that plus 3 state, there is a change in oxidation state of 3. So for every chromium atom, plus 6 state came down to plus 3 state or 3 electrons are gained. But in this formula K2Cr2O7, how many such chromium atoms are present? 2. Therefore, 3 into 2, 6. This is n factor. So, for a reducing agent or oxidizing agent, observe the changes in oxidation state and from there you understand how many electrons gained or lost like this. By observing the change in state per atom of chromium, I got 3 and then because there are 2 chromium atoms in the entire formula, I took 6. That means by whole unit K2Cr2O7, 6 electrons gained. That is our n factor. Therefore, here if anybody wants to tell what is equivalent weight of K2Cr2O7 in this, you must say it is equal to its molecular weight divided by n factor 6. Like that, equivalent weights are decided for oxidizing agents and reducing agents. Next class we make an assignment and some practice work we do, and while doing this practice work you understand better with some more examples.
డియర్ స్టూడెంట్స్, ఈనాటి ఎపిసోడ్లో కెమికల్ రోల్ టాపిక్ గురించి తెలుసుకున్నాం కదా. మరి నెక్స్ట్ ఎపిసోడ్లో స్టైకోమెట్రీ టాపిక్ గురించి తెలుసుకుందాం. అంతవరకు చూస్తూనే ఉండండి KAB టెలివిజన్.